Hi everyone, I'm Alex Hamer, a technical artist intern at SideEffects, and this video is a continuation on our video series on using editor utility widgets with the Houdini Public API. Today we'll cover setting up some inputs binding to instantiation and also manipulating properties of HDAs within a scene. So let's say, for example, that we have a HDA that utilizes a curve for generating meshes. Heading back to where we were at the end of the last video, after we just instantiated our asset and created a wrapper, we can drag out and search for bind, and then create an on post instantiation delegate. So this function will run once our HDA is done instantiating. So once the HDA is set up, we want to create a Houdini curve and also set it to be our input automatically. Firstly, we'll create an empty input object with a class of Houdini Public API curve input, and from there we can construct one in the scene and set our class to be Houdini Public API curve input object, which we can then promote. Please keep note of the two differences between these. With this, let's set our curve type to be a polygon, and you can set other types as well if you want, which you'll probably recognize from Houdini. For the sake of ease of use, so that the curve doesn't start out as a singular hard select point, I'll add a point at 0 and then another one at 500 units ahead, so that we have sort of starting point to drag out from. This is just something I like to do when I'm dealing with splines or curves, to make it as easy as possible. Let's go and grab our empty input and then call set input objects and connect our curve input object to this. After this, we need to call set input at index on our wrapper. This is what sets your actual HDA input like we see in the Houdini graph. So we set our input to be our empty input object from earlier, which of course is now not empty. So our basic process of setting an input to the HDA is, firstly, we create an empty input with a type of object it will be, for example, geometry, curve, or world type. Then we set our input objects on this empty input. If you're doing a Houdini curve as we just demonstrated, you'll construct a curve input object for this use, but you can also input any of the following types. Then we set our input at our Houdini index on our wrapper and input our empty input object, which we just filled with data. Now, if we test this, you can see as soon as I instantiate, it runs our script and it creates a new Houdini spline. If I start then dragging and manipulating this spline, given auto cooking is on, it should then automatically use this curve within the HDA as I ask it to. And as you can see, it's generating meshes along this curve. So now that we've covered inputs, there's actually a problem with our system at the moment, and that's that our wrapper is the only Houdini digital asset that we've just instantiated. What if we wanted to select another HDA of the same type in the scene and then manipulate that? Or what if we accidentally click on something else and then let go of our reference? Well, to do that, we actually have to make a function which wraps any HDA which we select in the scene. That means that when we select an asset, we can then instantly update its parameters or cook outputs. So if I make a new function, or you can make it a macro if you like, we can get our HDA active variable, which we created when we were instantiating. And we're going to be using this to expose to the user and allow them to select any HDA within the scene. Once that's done, we can get the API and call create wrapper on this, and then set our wrapper variable as this return. Similar to instantiation, let's also set our HDA actor. But to use this in a functional way, we have to have it so that the artist can select a HDA in the scene or via a menu. So if we head back to the widget designer, we can go to the Edits tab and drag on a single property view. As we learned before in the last video, we can link this object to be the variable that we set. So if we quickly do that by setting the variable name to be the exact same as our variable, and then also running a function which sets the object to be a reference to self. Now you'll see that it's showing the variable properly. So now to go back to fully setting up our wrapping function, we can create an onPropertyChanged event and then call our wrapSelectedHDA function on it. This means that we've created a system where we can either set a reference from the world outliner or pick it using the picker tool, and it will automatically wrap and update to this HDA. This means that any changes we make to parameters will now be on this HDA instead of another one. Next, we're going to set some parameters on our HDA. So the main idea behind using editor utility widgets is that you can expose specific parameters to the artist/user and forget all of the unnecessary ones. And you can also lay them out in an order that optimizes the workflow of using the tool. Using wrapper, we can then set an integer, a float, string, linear color, and also trigger a button parameter on our HDA. You can also do vectors, but you have to input each one as a float and add X, Y, and Z to the end, similar to what you would see when you add a channel reference in Houdini. You can also do ramps, but these are a tad more complex, so we'll get into those in a little bit. On our setParameter function here, we of course have the target as our wrapper. Our parameter tuple name will be the exact name of our parameter as it is in the Houdini HDA type properties interface. Our value will of course be a value that we set, and the index is the index of the parameter that we'll set the value at, but I often find that you don't need to change this. And finally, there's markers changed. If this is true, and if our HDA has auto cooking enabled, then this will cause it to recook. Here are some examples of all the different types of parameters. So ramps are obviously not a single parameter. They're an array of points with a value, position, and interpolation type. So using an example of float, we can set our ramp parameter points. And this goes back to an earlier video where I talked about how you display certain types of variables, and more specifically arrays. So single property view does not support showing arrays. So to get around this, what we'll do is if we create a ramp point and set it to be an array, then we can head to the designer and create a details view. This is fairly similar to a single property view, except we can actually choose which properties we want to set, and we can also show certain categories. So we can choose a specific variable to display, and this one can actually handle arrays, unlike single property view. So if we set our details view to show our ramp parameter with the exact same name, and as usual with this type of widget, we need to set an object reference to itself, and make sure you set the details view to be a variable as well, so you can actually access it in blueprints. And as you should see, it should display our ramp array variable. You can also display entire categories with this, as I mentioned, and there's a lot to explore here for customizability. So that's pretty much how you set parameters. Again though, with the problem I mentioned earlier when we have multiple HDAs in our scene, what if we change settings on one and then have to go and change them again after we've changed settings on another one, for example? We need a way of grabbing the information of the current HDA's parameters when we select it. So let's make a new function or macro, and we can call the exact same type of function, except instead of when we set the parameter, we actually get the parameter. We can then also set the out value as our variable. We can put this in a very large function which runs as soon as we select a new HDA of the same type. Unfortunately, you'll likely find that if you have a lot of parameters, this is going to be a very large and messy function, so be aware of this. That's pretty much parameters covered. In the next video, we'll talk about PDG topnet capabilities and how to do the basics, as well as some more useful functions with the Houdini Public API. Thanks for watching.